and also mechanical properties. I also put some clarified PP just to see what's the difference of this one. Crystallization and nucleation of semi-crystalline polymers. And we just put here that nucleation decreases crystal size, and we show it how it does, as I told you. This is another view of, you see that normally there are bigger crystalline areas, and in the nucleated one you have much more of the small crystalline areas, but they are so small that still it works and you have better aesthetics and better crystallization rates. So this is another view of what we have done. For example, we have done a case study as our home country for our main plant is in Turkey. There's only one local supplier of polypropylene in Turkey. It's called Petkim. It was ex-government company, now privatized. They were producing something about 144 tons of PP. So we go to them and we ask them, we need to make downgauging, but we need a stiffer PP. So what we can do together? So we can buy the material, if you can do it, some part of it, and we can lead other competitors, other colleagues in the industry to use it. So we call Milliken, which is making this product, and we make them join together. And they form the product, which used the highest kind of additive that they have. And the product was, now it's commercial, and what it had to us is that we increased the crystallinity, increased the rigidity, increased the heat deflection temperature, abrasion resistance, shorter cycle times, increased transparency, increased creep resistance, more uniform shrinkage, resulting in less warpage, and increased surface gloss. So this was the product that we were meant to for a big fast food chain. We didn't print it here, not to mention the name, but it's normally printed cup. They were having it in 16 ounce, 9.85 grams, and this was their consumption that they had. And they wanted to have 10% weight reduction without changing anything on the mechanical properties of the end product. And after using this, this material was achieved in the petrochemical plant, we achieved this 10%, and the outcome was satisfactory for them. They have had this product, and there was a lot of saving of the material, and also there was a lot of saving of CO2 emission. So it was a kind of an example how, as converters, we can also push the market for the petchem plants to go for more advanced material that will be good for downgauging. And I think that they need this, by the way, because at the moment, after the 2008 credit crunch, China made a lot of investment in-house for the petrochemicals, just to make the economy run again better. And these petrochemical plants, I think they started just this year. Some of them are on the way. And we see now that a lot of capacities in the Far East, like Taiwan, Singapore, Korea, that were meant to export the raw material to China, are facing hard times because China has its own petrochemical plants now. So it will be self-sufficient. And they have to export it to Europe, they have to export it to Turkey, any place other than the Far East, because Far East than China, because China has its own. So they have to make some kind of innovations, some special products that these markets need. So they are open, I think, more and more to listen to their customers in Europe and to find new innovations also for the raw material. Okay, and there's another way in the downgauging issue. It is the resin formulation, because we know that we can also, apart from the petrochemical plant, ourselves can make some formulations to make our resin more possible for downgauging. We know that we can use fillers. With fillers, we can have stiffness improvement, but the right kind of fillers I'm talking about. Stiffness improvement with no major loss and impact, cost reduction, shorter cycle times, faster cooling due to higher thermal conductivity of fillers. This is one of the cases. And the other case, which also is mentioned in one of the presentations, is also addition of expanding agents and new technologies that's possible to make it expand the products with a less weight product. That's also possible that we can use in downgauging after the petrochemical plant. This one we can do in-house with our own technology and own additives. So what we can do with these fillers, for example, talc, charger and nucleating at the same time, calcium carbonate, clay, mica, these kind of things. It can increase the heat performance, it can increase the flexural modulus, lower the shrinkage, warpage, lower down the, it increases the shrinkage, lower down the deformation, lower down the scratch resistance, and lower down the impact resistance. For the foaming agents, we know that there's a lot of products, additives in the market that we can use for reducing the weight of our product. Sometimes for the aesthetics, even some products it's needed that. There is the product additives, and also there is the technologies, like the Mucel technology and other things that we can do with the technology to reduce the weight of end products. There is also the, let's say, the very common thing in our industry is the designing factor, because after the raw material, petrochemical plant, after our own additions to the material, there's another chance that we can reduce the weight of the product, and that's introduction of ribs and walls for stiffness. There's plenty of designs and applications in our market, in the food packaging, that we have done for years to reduce the weight, which you have seen in the last 20 years, that's achieved in the PET bottles and the yogurt cups. So just a small examples, very, very simple examples that we all know how it changed the designs in the past and today, and the weights has changed. So improved mechanical properties by innovative product designs is one of the ways that we can also do downgauging. Yeah, products with unique geometries function with thinnest gauge, make it possible while still maintaining the requirements of the customers on the end product on the mechanical side. There's another thing that we can do to downgauge, and that's multi-layers. We can do multi-layer products, special multi-layer products, that allows us to make more stiff products and to downgauge our products in a better way. Before process optimization, I can tell another thing is how we can have the usage of recycled material in the downgauging. That's also an important issue, because when you want to use recycled material in downgauging, you need to have a better technology. You have told us of a super clean technology, and that technology is also good because it gives uniformity, which you can also make downgauging. That's also a clever idea. So also the recycling industry puts on a challenge for the downgauging, because when you have a material which is not like the original, with the gap of let's say precise is not so clear in the recycling compared to the original one, then you need better technologies for the downgauging. That's also an important issue. So then, at the end, we have another issue, is that we have the right raw material, we have the right additives, we have done all the things, and then the design, then there is the process optimization that we can do on the material to have good downgauging. We know that there's people who are in this industry, especially on this side, are experts on this one. But just to give a small, orientation is very important. I mean, if you orient the product in extrusion, then you can have better downgauging possibilities. So you can orient during the molding, which improves the strength, while downgauging, orientation in the mold, stretching during the thermoforming. This gives a special downgauging possibility. I know that in the industry, some of our friends has in the past even tried some special plug assists, which were moving one, which were stretching the material during the molding. And this was, for example, giving a better quality and better possibility for the downgauging, because it increases the mechanical properties. There's also possibility in orientation in films and fibers, tapes, increases the tenacity of the final product as compared to non-oriented products. And so we know that orientation is one of the alternatives. There is also possibility orientation post-extrusion. We know that this is used in the film industry, but there are some studies now in the machine industry to a little bit orient the rigid, even the films that they can do to increase the mechanical properties. So orientation is one of the possibilities that we can do. Optimization of processing parameters, which I told a minute ago. We can do a lot of things about the parameters that would let us to have more downgauging on the product. We can do mold and melt temperatures change, other parameters. This will lead to improved microstructure, improved crystallinity. This is one of the key issues in the mechanical issues, and semi-crystalline polymers. Then we know that there is also possibilities on the machine and the molds and the toolings and the plugs that we can do for the downgauging. Part design, which I told is one of the important things. Machine is very important. That's an injection machine, I know, but it was the beautiful one, better than the thermoforming machine we had on the picture. Mold design and material selection, all this add up again to make the right product. Just as an example, what can be done on the machining. We told about the right machines. We know that for downgauging we have to have precise machines, etc. That's for sure. There's a lot of things done on the innovation on the machining side for downgauging. Another thing is, for example, like the plugs. Plugs are very important in thermoforming. As I said, there's moving plugs, trialmans. There is plugs of syntactic forms, which is very new. I just put this one as an example what can be done on downgauging. So if you use a syntactic plug, you will have something about 12% downgauge. This is an example. I didn't put all the example here because it's not meant for going for the plug itself, but the idea how we can have the downgauging. So the parameters that we can do also, there's a lot of parameters that we can affect on the machines that we can have better downgauging. So I put some of them. The melt temperature, you see the impact changing. Impact is directly proportional that we can do when we are downgauging, is one of the important factors. We talk about shrinkage, warpage. It's again affected by the mold temperature. So our mold temperatures are important in case of when we are doing downgauging. Again, melt flow rate, when we are buying raw material, the difference in the rigidity, crystallinity, flowability, everything changes. So I don't go deep into that one because I know that a lot of people here already know these things, but molecular weight distribution of the end product, that's also important in the mechanical properties. Crystallinity, and finally, downgauging is the biggest weapon for replacements of glass, cardboard, wood, etc. So, as I told in the first phase, downgauging is not just a consumer request, but it's also a good possibility, and we should have aggressive plans, aggressive programs. It's a must. It will give us a competitive edge. It will let us compete with other, let's say, Far East producers, but also it will have a lot of replacements, because when we are talking about replacements, we should also think that if we are talking about glass, cardboard, wood, etc., they don't have such beautiful product like plastic that they can downgauge so easily. So we talk about 9 billion people coming, scarce sources, and even though there are some negative approach to plastic, there is also a great requirement for the plastic. And downgauging will be one of the important factors. And our competitor products in the packaging, they don't have such good product that they can easily downgauge. So this is a good advantage. And I say why? Because plastics do it better. Thank you very much.
Well, we've always said plastics are fantastic, so it's the same thing. Any questions, ladies and gentlemen? No, please.
I didn't hear you say something about moulding. I mean, the mould costs are quite important. So if you start downgauging, for example, there's fillers, there's stiffeners, and so on. You have to change moulds, or you won't keep the dimensions, or shrinkage is different, and so on. So is that something that hinders you from downgauging, or mould costs are very high very often?
100%. I mean, mold is one of the part of the equipment that you are, it is affecting the downgauging. I just take the plugs as an example, but 100%. I mean, mold is also one of the most important parts